Okay, in this video we're going to talk about how to determine the inverse of a function and an inverse function. So those two terms are often interchanged, but they're not always often interchanged, but they're not always true in both circumstances. So just like, let me make an annotation here. So if I look at a function, so we'll say let a function exist as, we'll just call it f of x. And when I draw this function f of x, I'm just going to draw a parabola. So let's draw a parabola that opens up and looks something like this. So the way that we denote the inverse function, we're going to say that the inverse of f of x is annotated f, and then it's going to be superscript f superscript -1 of x. But remember, I'm just going to put a little star here because this is important. F -1 of x does not equal to 1 over f of x. So this is special notation to indicate an inverse function. So the inverse or the inverse of f of x. So I will show you in this circumstance that we notice here that f of x is a function. Remember, we always talked about a graphical way of determining a function by looking at a vertical line test. And the vertical line test states if you draw a vertical line anywhere throughout your function, anywhere throughout the graph, as long as it intersects at most one point meaning that could also be 0 points or 1 point, but not 2, 3, or 4, or 5 or 6, or anything larger. If we take a vertical line and we put it anywhere here, we recognize that it's only going to hit our graph at most once. So we recognize that f of x does pass the vertical line test. And even though I haven't described how to find this at this point, f inverse of x is going to look something like this. So it's going to look something like this. Well, maybe it's a little too wide. Let me redo that again. So maybe it's going to look something like this. So here we go. So notice in this circumstance that this is f inverse of x, and at this point you don't know how to determine that, but I'll show you that later. But hopefully we recognize that f inverse of x is not a function. So because if I draw a vertical line anywhere through this graph, notice here I hit the graph once and I hit the graph twice, and that violates my vertical line test. So in this circumstance, f of x is a function, but its inverse is not a function. So that's why we say that we have inverse functions and inverses of a function. Because in this circumstance, f inverse of x may or may not be a function. And remember, we always like working with functions. So that's the reason why in that last video, we discussed a very important topic called one-to-one functions. Because one-to-one functions have another unique property. So we'll just talk about one to one functions have an inverse that is always a function. So this actually brings up our second topic, which we're going to talk and discuss about at length, called inverse functions. So this is going to be inverse functions. So we're going to talk about this at length, and that's more specific because we want to talk about a circumstance where we always have a function, where the inverse is always a function. So sometimes we could, if we looked at this, if we looked at that last problem, if we looked at f of x equal to x squared, in this circumstance, when we draw this, we recognize this is a parabola, and this opens up, like such. Sometimes what we want to do, or sometimes what we can do, is that we can restrict the parabola's domain such that the inverse is a function. So if the inverse of f of x is not a function, you can restrict the domain such that the inverse is a function. So, if we were to examine this portion, graphically, we recognize that f of x equals x squared as a function. Our inverse of f of x, of f of x, is equal to plus or minus square root of x. So notice here we have the positive square root of x at this side, and then the negative square root of x down here on this side. So now we recognize that our inverse is not a function. But let's say that we restricted our domain, and we restricted our domain here to start at 0 and then continue on to infinity. So that means that we would no longer examine this left portion of the graph, or the negative x-axis portion of the graph. Everything that's only positive would be included in our function. And what does that do? Is that if we remove the negative x portion, then we're also going to remove this portion that exists here below the x-axis. And this negative square root of x goes away. So now, when we did this, f inverse of x is a function. So now that our inverse, this is a function. So sometimes you can restrict the domains. Actually, you can do this pretty much all the times. We can restrict the domains of any function such that such that the inverse is also a function. So in this circumstance, we can clearly see that now we pass the vertical line test. So that brings us to more of a formal definition of an inverse function. So let's go ahead and just discuss a little definition here of an inverse function. So let us say that suppose suppose that f is 1 to 1. So again, that 1 to 1 comes up again. That 1 to 1 function is coming up again because it has some very unique characteristics on a domain. We're going to call that domain D with a range, and the function has a range R. So the domain is D and the range is R. I don't know why I capitalized 1. This really doesn't need a capital R, so I guess I can erase that. So it has a capital, so just a little range R. The inverse function f to the negative 1 is defined by f to the negative 1 of b is equal to a if f of a equals to b. Then we describe the domain. So we say the domain of f inverse is the range of f of x, or I'm sorry, of f, and the range, oops, too many of those, and the range of f inverse is the domain of f. So this gets a little bit weird with this notation, but again, we want to work this through and discuss this at length. So this I guess is a more formal definition of how we define an inverse function. And basically what this means, and this is sort of a quick summary that is very liberal, is that if you want to find the inverse of a function, every value of x becomes y, and every value of y becomes x. And we're going to explain that a little bit more in depth in our next video. But lastly, when we talk about the domain, this is a very important characteristic, is that if we were to describe, so let's say that we have a function, we say a function g of x. The inverse function of g of x is g inverse of x. So we call it g to the negative 1 of x. Remember, that doesn't mean 1 over g of x, so be very careful about that. So here, if we describe the domain of g of x, the domain of g of x will become the range of g inverse of x. And the range of g of x will become the domain of g inverse of x. So we'll show you how these properties hold true in our next video series. But just remember, the domain of the function becomes the range of the inverse, and the range of the function becomes the domain of the inverse. And those are two important characteristics that we want to recognize when it comes to a function and its inverse function.